For our second example, we want to solve the system 2x squared plus y squared equals 24, and x squared minus y squared equals negative 12. So, with this one, hopefully you can see that even though we've got a whole bunch of squares in here, the y coefficients and the y exponents still line up, basically in exactly the manner we want in order to be able to eliminate them. So, if we take 2x squared plus y squared equals 24, and x squared minus y squared equals negative 12. My spacing looks weird there, but if you add these up, you'll end up getting here 3x squared is equal to positive 12, because 24 minus 12 is 12, and 2 plus 1 is 3. Then 1 minus 1 is 0. But you get that, divide out the 4, and you will end up having that x is going to be equal to plus or minus 2. And then because x is equal to plus or minus 2, if we want to get y, we can just play that same plug and chug game that we did before. That if x is equal to 2, we would then have, using either of these equations really, and we use the second one because it's a little bit simpler, 2 squared minus y squared, 2, bad, equals negative 12, which I'm going to skip a couple of details here, pulling over that 2 squared dividing out the negative 1 would leave us with y is equal to plus or minus 4. And then essentially the same thing happens if x is equal to negative 2, because when x is negative 2, we get negative 2 squared minus y squared equals negative 12, but negative 2, let's be careful with where that square is, that actually does make a difference. Because with that square on the outside, that still just ends up being a 4, so y also just ends up being plus or minus 4 again. And because y is equal to plus or minus 4 here as well, we would have that our solutions, to be a little bit more exacting this time, consist of the sets 2, 4, negative 2, 4, 2, negative 4, and negative 2, negative 4. As shown by the graph here, where, to be sure, we call that first equation with an x squared plus a y squared term a ellipse. It's got that elliptical shape, while the second, with those things flipped out that way, is what's called a hyperbola. For those of you that are going to go on and see anything with conic sections, it's worth being aware of how those things come together. But process here, again, basically the same, just, you get exponents now, so you got more things. And the last thing we're going to do here, last thing we're going to do for this section, is take an application.